Hey everyone, and welcome back to The Explainer. I am so incredibly pumped you're here with us today because we are going on a cosmic journey. We're going to zoom out from our tiny blue marble and take a really structured, absolutely fascinating look at the star system right next door to us, Alpha Centauri. We'll be breaking down the unbelievable distances, the stars themselves, the planets we've managed to find, and how humanity might actually travel there one day. So get comfortable and let's launch right into this. But, before we get too deep into the cosmos, I kind of want to test you with a classic trivia question. What is the absolute closest star to Earth? Do you think you know it? Well, if you said Alpha Centauri, you completely fell for the trap. The trick answer is, of course, our very own sun. It's a bit of an old joke, I know, but it perfectly pivots us to the actual subject of today's explainer, our second closest stellar neighbor, the Alpha Centauri system. Section 1, our closest stellar neighbors. Okay, let's dive into this and start zooming out away from Earth's night sky. To really grasp this star system, we have to understand exactly where it sits relative to us and just how vast the cosmic ocean really is. 4.24 light years. That's the exact distance to Proxima Centauri, the closest individual star in the Alpha Centauri system. Now, 4.24 light years translates to roughly 40 trillion kilometers. When you think about the Milky Way galaxy being 100,000 light years across, this is literally a mere cosmic stone's throw. They're our next-door neighbors. But for our current spacecraft, yeah, it's a staggeringly massive gulf. Section 2, meet the three stars. Let's transition a little deeper into the galaxy and actually zoom in to meet the three individual stars that make up the system. So, Alpha Centauri isn't just one star. It's actually a triple star system. On one side, we've got Alpha Centauri AB. This is a super bright, massive pair of stars that are very similar to our sun. On the other side, though, we have Proxima Centauri, which is this distant, extremely faint red dwarf. So if you're ever in the southern hemisphere looking up at the night sky, you only see that bright pair, A and B. They just blend together to look like a single brilliant star to the naked eye. Now, what's really interesting about this slide is how these three siblings actually compare to our own sun. Alpha Centauri A is a G2-type star. That means it's exactly like our sun, just a tiny bit more massive and slightly hotter at around 5,800 Kelvin. Then you have Alpha Centauri B, which is a K1-type star, so a bit more orange, slightly smaller than our sun, and a little cooler. But then there's Proxima Centauri. It's an M-class red dwarf. It literally has barely 12% of the mass of our sun and is significantly cooler. It's basically a tiny, faint ember compared to that bright central pair. So Alpha Centauri A and B make up what we call a binary star system. That simply means two stars orbiting around a common center of mass. Because they are gravitationally locked in this dance, they really are the focal point of the entire system. And A and B are locked in quite the orbital dance. They share a highly elliptical orbit that takes about 79 years to complete. Back in 1955, they made their closest approach to one another at 11.2 astronomical units. Just to put that into perspective for a second, that's roughly the distance from our sun to Saturn. Then, in 1976, they swung way out to their widest separation at 35.6 astronomical units, which is about the distance from our sun all the way out to Pluto. And get this, their next close approach is coming right up in 2035. But where does that tiny red dwarf, Proxima Centauri, fit into all of this? Try 13,000 astronomical units. That is how far away Proxima sits from the central A and B pair. It is gravitationally bound, sure, but astronomically distant. We're talking equivalent to about 430 times the radius of Neptune's orbit. Because it's pushed so incredibly far out, it actually takes Proxima over 500,000 years just to complete a single orbit around the central pair. Section 3, exoplanets in the system. Now let's zoom in even closer to check out some tantalizing evidence of actual planetary bodies orbiting these stars. Okay, so we know the stars. Now let's look at the planet roster. It is absolutely crucial here to distinguish between what's confirmed and what's still hypothetical. Orbiting the red dwarf, we have Proxima B and Proxima D, and those are both scientifically confirmed planets. We've also got Proxima C, which is a candidate right now. And orbiting the sun-like Alpha Centauri A, we have another candidate currently known as Alpha Centauri AB. So the crucial point is really looking at this data from the NASA Exoplanet Archive. Proxima B is a massive focus for us. It's just over 1 Earth mass, and it completes a full orbit in a blistering 11.2 days. But because Proxima's such a cool dim star, that fast 11-day orbit actually puts Proxima b squarely in the habitable zone. Then you've got Proxima d. That's a tiny sub-Earth world at just 0.26 Earth masses, zipping around its star in just over 5 days. Of course, no scientific journey is without its hiccups, right? Which brings us to a major plot twist. You might have noticed, there are no confirmed planets listed for Alpha Centauri b. Well, back in 2012, astronomers made global headlines announcing an Earth-mass planet called Alpha Centauri bb, but it was a false positive. By 2015, meticulous follow-up research proved that the planet was actually just an artifact of how the radial velocity data was processed. It's honestly a fantastic reminder of how rigorous the scientific method really is. But hey, don't lose hope for this central stars just yet. First imaged in 2021, Candidate 1, or Alpha Centauri A, is a potential planet orbiting the sun-like Alpha Centauri A at about 1.9 astronomical units, and follow-up observations have continued right through 2024. If this gets confirmed, this object would be massive, somewhere between 90 and 150 Earth masses, which puts it right in the Neptune to Saturn size range. And guess what? It sits right in the habitable zone of star A. It's an incredibly exciting target for our future telescopes. Section 4, Future Interstellar Travel. Let's zoom back out for a moment and look at human ambition and answer exactly why this matters to us. We've mapped the stars, we found the planets, but the real question is, how do we actually get there? With our current conventional chemical rockets, it would take millennia. Thousands upon thousands of years just to cross those 4.24 light years. But laser light sails offer a totally different path. Initiatives like the Breakthrough Starshot program are proposing we use powerful Earth-based lasers to propel tiny spacecraft attached to light sails. By pushing them to a fraction of the speed of light, we could theoretically arrive in just 20 years. No way, right? And this brilliantly illustrates a concept NASA released back in 2017 for a mission launching in 2069, meant to coincide with the 100th anniversary of the Apollo 11 moon landing. Okay, check out this timeline. Step 1, launch. Step 2, travel at roughly 10% the speed of light for 44 years. Step 3, the probe arrives in the Alpha Centauri system in the year 2113. Step 4, because radio signals only travel at the speed of light, it takes 4 more years for that data to beam back, finally arriving on Earth in 2117. The entire goal of all this crazy math and engineering is summarized perfectly right here. An objective of such a mission would be to make a flyby of, and possibly photograph, planets that might exist in the system. Just imagine it for a second. High-resolution photos of Proxima b actually beamed back to Earth to see with our own eyes the surface of an exoplanet in the habitable zone of our closest stellar neighbor. It's literally the ultimate awe-inspiring dream of interstellar exploration. So, I want to leave you with this final, provocative thought. Will humanity successfully launch a probe to Alpha Centauri by 2069? Will you, or maybe your grandchildren, be around to see the very first close-up images of another solar system? The science is already underway, the target is locked, and the universe is waiting. Thank you so much for joining me today. If you enjoyed this explainer, keep looking up, keep asking questions, and I'll catch you in the next one.